Today on How It's Made. Conga drums. Metal plating. And buttons. The conga drum may be a staple of Latin American music, but it was developed from an ancient African drum, made from an animal skin stretched over a hollow tree trunk. Today they stretch the hide over a wood or fiberglass cylinder. As you're about to see, making congas takes plenty of hands-on skill. These congas are made of ash, a wood that has good acoustics. That means sound resonates off of it, rather than being absorbed into it. First, the drum maker cuts the curved slats that will form the drum's body, called the shell. He traces a slat-shaped template on a rectangular piece of wood. Then, using a bandsaw, he cuts along the trace line, creating a curve on the outside and inside surfaces. Then he moves to a bench saw, a saw whose blade can be adjusted to different angles. He clamps the piece onto a template and angles the edge. He flips the piece over and angles the other edge. The drum maker applies carpenter's glue to both edges and clamps the slats together in a circle on a specially designed form. The number of slats per drum varies depending on the diameter of the shell. The larger the diameter, the lower the congas sound. The glue dries in 24 hours. It comes off the form looking like this bongo shell, but taller. The drum maker now mounts the dried shell on a wood lathe. Using a tool called a wood gouge, he shears off about 2/10 of an inch, rounding the outside of the shell. Then he uses a series of woodworking tools to add decorative detailing. Once that's done, he smooths the shell's surface using 3 progressively finer grains of sandpaper. Then he either leaves the wood its natural color or stains it. A thick coat of oil-based lacquer protects the wood from both dryness and humidity. Now for the essential hardware. First, side plates made of chrome-plated steel. Their job is to anchor the drum's animal skin head. They're bolted to the shell. Next, the drum maker feeds a steel strip through a bending machine. Its high-pressure rollers curve the strip, forming the drum's rim. Then, he rivets V-shaped steel pieces onto the rim. Elsewhere in the workshop, they prepare the cowhide that will become the drum's head. First, they soak it in a corrosive bath of cold water and lime. This literally burns the hair off the hide. After 2 or 3 days, they remove the skin and scrape off any stubborn hairs. Then they stretch it over a circular frame, leaving it to dry at room temperature for a couple of days. After chrome plating the rim, it's time for the final assembly. They stretch the head over the shell and clasp it in place with the rim. They hook the V's to the side plates, then adjust the tension to tune the instrument. The last step is to trim off the excess skin. Now, the musical handiwork can begin. Plating is a layer of metal coating an object made of a different type of metal. The purpose can be decorative, as in silver plating, or practical. With industrial parts, for instance, zinc or cadmium plating prevents the underlying metal from rusting, while nickel or chrome plating protects against wear. You can plate almost any type of metal. Let's follow some steel aerospace parts as they're about to be plated with cadmium to make them corrosion resistant. For the plating metal to bond properly, the steel surface must be free of contaminants such as oil and grease. Workers suspend the parts over a vat of boiling chemical solvents. As the hot vapor comes in contact with the colder metal, it condenses, dripping down into the vat and taking any contaminants along with it. The remaining solvent residues evaporate, leaving the parts squeaky clean and dry. Next, a worker wearing protective clothing sandblasts the parts with aluminum oxide powder, a strong abrasive. This roughens up the surface so that the plating metal will adhere better. The most common plating metals for industrial purposes are zinc, chrome, and nickel. Think motorcycle parts or sink faucets. Decorative items, on the other hand, are most likely to be plated in tin, brass, gold, or silver. Traditional tea sets, for instance, are often made of silver-plated copper or zinc. The plating process is called electroplating because the key is electricity. They start by tying strands of copper wire to a copper support frame. Copper is the best metal for conducting electricity. Then they attach the steel parts they'll be plating. When they hook up this support to an electric current, electricity will run from the support through these wires, right to the pieces. They do the electroplating in a tank. After filling it with water, they add a handful of chemicals to help conduct electricity, because water alone won't conduct it sufficiently. Along the sides of the tank in bags are metal baskets. They contain bars or balls of the plating metal, in this case cadmium. Workers connect the support frame with the steel parts to the negative terminal of an electric source, the baskets of cadmium to the positive terminal. Then they switch on a steady DC current, no stronger than 6 volts. The electricity dissolves the cadmium, lacing the particles with a positive charge. They travel through the water and attach themselves to the negative charged steel parts. This creates a smooth and even layer of cadmium. Thin plating requires just a few minutes in the tank. Thick plating, several hours. Then, workers rinse the parts in water for about a minute to remove the chemical residues. To make the parts even more rust-resistant, workers immerse them in a series of compounds. This triggers a chemical reaction in the plating, enhancing its ability to withstand corrosion. This reaction, however, changes the color. A final rinse in hot water, and this cadmium-plated steel aerospace part is finally ready. From start to finish, The process has taken about 90 minutes. To plate with chrome or gold, they have to use a chemical compound containing gold or chromium. That's because electricity can't dissolve solid chromium well enough, and it can't dissolve solid gold at all. The compound dissolves in the bath like salt, but then solidifies once it reaches the object being plated. Metal plating is very durable, but if subjected to a lot of wear and tear, the object will eventually have to be replated. Have you ever wondered why men's buttons are traditionally on the right side of a garment and women's on the left? Legend has it that this enabled a man to unbutton his coat with his left hand while drawing a sword with his right. Wealthy women, meanwhile, had their buttons sewn on the left side to make it easier for their right-handed maids to dress them. One way to make plastic buttons uses a multi-layer sheet of synthetic resin, hence the industry term sheet buttons. Workers start by mixing liquid polyester resin with a catalyst to gel it. They pour the material into a revolving drum which disperses it evenly. They spray a solution containing an ultraviolet pigment on this first layer only. You'll see why later on. For this particular model, they make grooves in the resin while it's still malleable. This will create a design. After about 5 minutes, the resin gels and they can mix and add a second layer in a different color. Besides building up the thickness of the sheet, the resin flows into the first layer's grooves, creating a design of contrasting lines. Once this second layer gels, they mix and pour in a third color. The drum spins for another 10 to 15 minutes until all layers cure. A resin sheet can be comprised of up to 4 different color layers. Workers can now remove the sheet. It's hardened enough to be cut into buttons, but it's still flexible enough not to crack when cut. They feed each sheet into a press that's outfitted with the die for that particular button model. The press punches out circles in the diameter of the button. These circles are called blanks. Here you can see the different color layers. The blanks move on to the machining center, where they'll be transformed into buttons. Automated equipment loads them onto carousels, with the back of the blank facing outward. How does the loader know which side is which? Remember that ultraviolet solution the workers sprayed onto the first layer of resin? A UV detector scans each blank to make sure the first layer is facing upward. If it isn't, the machine rejects the blank, then flips and reloads it. The carousels first run the back of the blank against a series of cutting heads. The heads are changed according to the model being produced. For this one, the heads gradually carve a curved back. The equipment then transfers the blank onto a second carousel, exposing the front side this time. Again, a series of cutting heads gradually carve the front of the button. The shape of this model exposes the different color layers underneath, creating a veined effect. The last cutting head drills the holes. Here you can see the full progression, from blank to button. Now they polish the buttons for several hours in drums containing abrasive ceramic stones and pumice. Then workers flush the drums with water. The heavy polishing stones sink to the bottom, while the lightweight buttons float to the surface and spill out. The buttons then go into drums that contain silicone wax and thousands of tiny wooden pegs. While the drums spin, the pegs act as a carrier, distributing an even coat of wax. As the buttons exit the drums, the pegs are screened out. From here, plain buttons are often custom dyed to match fabric swatches provided by clothing manufacturers. Archaeologists have unearthed bone buttons dating back to prehistoric times. The ancient Greeks and Romans used buttons to fasten and decorate their clothing. Europeans wore buttons strictly for adornment until about the 1200s. That's when fitted garments became the trend, fastened by a long row of buttons down the front. The rich wore buttons made of silver or gold, sometimes set with precious gemstones. Ordinary people wore buttons made of bronze or wood. This is another way to make plastic buttons using polyester resin. Only instead of turning it into sheets, they pour the resin into long metal tubes. Here they're mixing two different colors to create a design in the plastic. The tubes go into an oven, where they bake at 212 degrees Fahrenheit for about an hour, until the liquid resin hardens. Once the tubes cool off, workers remove the contents. These long resin rods will become what the industry calls rod buttons. The rods go into a machine called the slicer. Its sharp carbide blade chops the long rods into button-sized blanks. Here's what that looks like in slow motion. It's no use showing you this at regular speed. It would be but a blur. This machine cuts up to 700 blanks per minute. Blanks cut from resin rods run through the same machining center as those cut from resin sheets. In the last segment, we showed you the machining steps in slow motion. Here's what they look like at actual speed. Any type of button can be engraved with the company name or logo. They do this using a computer-programmed laser machine. The laser beam burns the lettering into the plastic. Workers visually inspect the finished buttons to make sure that none have defects. A third way to make plastic buttons is a method called thermoset compression, a technique that combines both heat and pressure to mold the button shape. As we see here in slow motion, the raw material isn't liquid resin, but rather melamine powder. A pill-making machine, the kind pharmaceutical companies use, compresses the powder into pill-shaped blanks. Here's what that pill-making action looks like at actual speed. To transform these pills into buttons, workers load them onto a press. The press uses high pressure to force each pill into a button mold for a period of 40 to 60 seconds, depending on the size of the button. At the same time, it heats the mold to 325 degrees Fahrenheit. This bakes the melamine into hard plastic. They cool the molded buttons in a basin of cold water. Some specialty buttons will be gold-plated, but not before soaking in a chemical bath to clean their surface, so that the plating will bond well. As a rule, only materials that conduct electricity can be metal-plated. Plastic, of course, is non-conductive. This company has managed to devise a way to gold-plate plastic buttons. Exactly how is a closely guarded secret it's not willing to divulge. After plating the buttons in copper, a 12-hour process, they plate them in nickel, which takes just a couple of minutes, and finally in 24-karat gold, which takes just a few seconds. A mere 1 ounce of gold is enough to plate 180 pounds of buttons. Thermoset compression buttons are a lower-end product used primarily for uniforms. Sheet buttons and rod buttons are higher